everyone, and welcome to day 15 of solving LeetCode problems on Tom hired by a FAANG company. Today we're going to be solving 1701 average waiting time. So there's a restaurant with a single chef. You're given an array of customers where customers I equals arrival and time. Arrival is the arrival time of the ith customer. The arrival times are sorted in non-decreasing order. Time is the time needed to prepare the order of the ith customer. When a customer arrives, he gives the chef his order, and the chef starts preparing it once he's idle. The customer waits till the chef finishes preparing his order. The chef does not prepare food for more than one customer at a time. The chef prepares food for customers in the order they were given in the input. Return the average waiting time of all customers. Solutions within the 10 to the minus 5 from the actual answer are considered accepted. So for example, we have 3 customers here. The first one simply takes 2 minutes, right? The second one, however, arrives at time 2 and the chef takes his order and starts preparing it at time 3, since it was the time at which he finished the previous order. So he finishes at time 8. And we add the additional waiting time, which would be 6. So we have 8 as the total waiting time for the moment. And the last one, well, would be the same thing, but this time 7. So if we add 2 plus 6 plus 7 over 3, that is equal to 5. Okay, so this actually problem also seems kind of straightforward. Like we would just need to keep iterating through our customers and just keep track of basically the time that the chef finished preparing the previous guy's order, right? So for example, we could have this same example right here. Let's just remember that our output should be 5. Right, so we're going to need a variable for the total time that our customers have been waiting. So total time at the moment is going to be equal to 0. And also, well, the previous time at which the chef finished the previous order. Right, which in this case could also be initialized at 0 or probably 1, since we're hopefully always going to start at 1. We could even just initialize it at this just first value, right? And well, having said that, we could also start checking. So added time is going to be equal to the formula that they use in this same example, which is basically the previous time plus how much it takes, right? Which is going to be previous time plus customer at 1, and in the end we're simply going to subtract customer at 0. Now I'm just realizing something here, like maybe this could be a negative value. If previous time is less than customer 0, we should probably not do anything, right? Like if previous time was 0, we finish at 0. Well, a customer didn't wait any additional time, right? He just waited the amount of time it took him. So it would be just customer 1. So we just need to keep track of that. So if previous time is greater, right, than customer at 0, we would start doing something like this. Else we would just add time would be equal to customer at 1, right? Like something like this probably. And well, we would also need to assign the new previous time, right? We should be a little bit careful with that. Right, so let's just go ahead and iterate through this example real quick. So once we have this, right, previous one is 1. So this is actually, given this condition, we would just add time would be equal to 2. We could add it to total time. This for the moment is going to be equal to 2. And previous time is going to be equal to this, if I'm not mistaken. Probably something like this. Let's see. So this, for the moment, it would be equal to previous times equal to 1 plus customer at 1. This would now be 3. So this is going to be equal to 3. So we would iterate now through our second customer, which has values 2 and 5. So now is previous time 3 greater than customer 0? 2, it is. So at time is going to be equal to 3 plus 5, which is 8, minus 2, which is, the result is going to be 6. So we're going to add 6 to the total time. This is now going to be equal to 8. And previous time is going to be equal to previous time plus customer at 1, which in this case is going to be 8, right? So we're also going to have now this same value. I'm not super sure if having 2 separate variables would be good, but just to keep it maybe more readable, I'm going to keep it like this. So now we would finally iterate through our last customer, which has the values 4 and 3, and let's see what happens. And yeah, once we have iterated through all our customers, we're simply going to divide total return total time over num customers. And that would basically be it for our algorithm. Now let me just quickly check if this would also work for our second example. And here, before even iterating through our customers, I'm just realizing that previous time is also going to be dependent of this condition. So here we could probably add previous time because it does matter to the whole equation. But if not, we're simply going to do previous time is going to be equal to the added time to customer 0 plus customer at 1. This should be even more correct. This way, we could actually just initialize every time previous time at 0. And now let's go ahead and see if this would actually work with example 2. I believe we can start coding something like this up, right? So we're going to need our variables. Total time equals 0. Previous time equals 0. We're start going to iterate through customers. In customers. I might also want the length of customers just to have it. N equals length of customers, so that in the end, we should simply return total time over n. That would basically be it. So now let's start doing the logic for the for loop, which should be basically what we have here. So if previous time is greater than customer at 0, which is start, the added time is going to be equal to previous time plus, it's not actually end, it's actually the time it takes. So I'm just going to call it duration. So previous time plus duration minus start, and previous time is going to be equal to previous time plus duration. And actually, just instead of having the variable of add time, we could just add it to total time. So total time plus equal this. And well, else, if this is not the case, we're simply going to do the other part of our logic, right? So added time, so total time is going to be plus equal customer at 1. So it's simply the duration. And previous time, which here needs a capital letter here as well, is going to be equal to customer 0, which is start plus duration. And I believe that would basically be it. This algorithm, the time complexity for this algorithm would be basically O of n. So I believe it is pretty efficient actually. Now let's just see what happens if we run this. So unknown network error, okay. Okay, so our 2 test cases have been accepted. And finally, let's see what happens if we submit this. Okay, and there it is. We have successfully completed day 15. Here it says that our runtime beats only around 25% of users, and memory-wise as well. I mean, memory-wise, we are using a couple of variables, but I believe this adds a lot of readability. However, the runtime for this does surprise me a little bit. Let me just see what happens if I submit it once again. Okay, now memory-wise, looks like we beat almost 100%, and runtime has downgraded by a lot. Nevertheless, I'm still very happy with the solution. And well, if you found a more optimal solution, go ahead and tell me in the comments below.